For this set of math notes, you will need your lucky math statue, a picture of your grandpa and grandpa, and the sun. Okay, here we go. So, we are going to do this question right here. I'm going to cover up my work because I already started. So we're going to find the domain and range of this function here. This negative sign right here is going to make it open to the left. Okay, so you need to know some of these shortcuts. To find the domain, I'm going to take this and I'm going to set it greater than or equal to 0 because it can't be negative. I'm going to distribute the negative inside the brackets. I'm going to get negative x minus 1 greater than or equal to 0. Okay, and then I added 1 to both sides, so now I get this statement here. When I multiply both sides by negative 1, my inequality sign flips, and I actually missed my negative sign here. So I'm just going to redo that. You're going to get x less than or equal to negative 1. So the x values that I can plug into this have to be less than or equal to negative 1. So my domain is going to be x less than or equal to negative 1, x element of the reals. For this one here, it's opening to the left. It's not going to be underneath the x-axis. That can happen sometimes. But in this case, if the negative is under the radicand, it's probably going to be above the x-axis, okay, as long as there's a positive out here. So my range is going to be y greater than or equal to 0. Okay, so now I'm starting to graph this thing. So just need a little table of values. I'll just do it right here. Okay, so I have to plug in numbers that are less than or equal to negative 1. So negative 1 is a good one to plug in. So when I plug it into here, I'm going to get 0, negative 0, which is still just 0. So at the point negative 1 for x, there's my x-intercept. Okay, and then pick smart points. Pick points that are easy to do the square root of. So negative 2 is going to be a good one, because when I go negative 2 plus 1, I'm going to get negative 1 in the brackets, times the negative, I get positive 1. Square root of positive 1 is 1. So that's my y value. So negative 2 for x, and positive 1 for y. So right there. And I know it's going to open to the left, so that is enough to start doing that. And there's my sketch. So I can see that my range is indeed y greater than or equal to 0. That one's done. Let's do another. Just as we switch, let's enjoy this wonderful statue. I'm going to find the domain and range and graph of this radical function here. I'm just going to point out that if you have a negative outside the radical sign, it's going to reflect over the x-axis. First thing I like to do is figure out what I can start plugging in. So for x plus 1, I'm going to set it greater than or equal to 0, because that's the condition that has to happen in there. And I'm going to solve, and I'm going to get that the x values I plug in have to be greater than or equal to negative 1, which is great. So if I plug in negative 1, I'm going to get the square root of 0. Go ahead and plot that. So negative 1, 0 happens to be our x-intercept of that function. When I plug in 0, I'm going to get this 0 plus 1. So square root of 1 is 1, and then there's the negative. So this is where we start to see it reflecting over that x-axis. So 0 for x, negative 1 for y. So it's going over. If I'm not going to plug in 1, because that's not an easy, I'm going to get 2. I don't want to do the square root of 2. But if I plug in 3 for x, then I'm going to get the square root of 4, which is 2, and then the negative. So I get negative 2. Okay, that's more than enough info to give myself a sketch here. And we're done. So, domain. We figured that out. Oh, you can always find out your domain by taking the radicand and solving the inequality when it's greater than or equal to 0. So I'm just going to write that x is greater than or equal to negative 1, x element of the reals. For my range, so this is an example where our range can indeed be those negative values for y. So my range is going to be y less than or equal to 0, and y is an element of the reals. Okay, last question that I wanted to cover. Focus. Come on. Okay, so just wanted to find the equation for this beautiful little graph. Put some nice little arrows on there. A couple issues on the last test with this one. So this is, some parts of it are grade 11 type knowledge. So from grade 12, we know that when we see the graph bouncing back at the x-intercept, then that means we have an even multiplicity. So we have even multiplicity at two different spots. So a good place to start with my equation is y equals. Now, and this is the part that I really want to mention. In grade 11, in the factored form of a quadratic, there is an a term, okay? Then this x-intercept, so if it's x minus 1, the binomial has to be x plus 1, so that when I solve it, I would get minus 1. And because since it bounces back, I'm going to put a squared there, so we have an even multiplicity. This one here, if x equals 2, going backwards, then my binomial would have been x minus 2. And again, because it bounces back, even multiplicity. Now, to figure out this a term, I need to plug in a point on the graph. I can't use the x-intercepts. I already used those, so I can use the y-intercept. That's a very convenient point. I do know, because it's opening up on both sides, the end behavior, I know that my a term is going to be positive, but I need to know positive what. So I'm going to plug in the point, 0 for x, 10 for y. So I'm going to write 10 equals a. Going to plug in 0 for x, so 0 plus 1 squared is still just 1. And then 0 minus 2 squared is going to be 4. So I get 10 equal 4a, and just about done. I'm going to get 5 over 2 when I divide both sides by 4. So final equation. Okay, and that's the final equation. So please don't forget to solve for that a term. Usually I'll give you a point, so it'll be obvious because usually we put a dot on the graph of an easy point to use. So I hope you enjoyed these notes, and see you next time.